All right, better late than never. Just things pop in all day long. That just made it that I wasn't able to make this video till starting at 2:55. So it's all good. And then hopefully we have this watched and ready by my Thursday crew, who I will look at this worksheet on Thursday and see what you got. Anyone that doesn't bring it, it's on you. I mean, I'm tired of the people not bringing their papers. I just think it's a trick that we don't have to. If I don't bring my papers, then he can't do anything about me doing my homework. Well, just it's not good. Some of us playing these games. All right. Anyway, let's not talk about that. Let's talk about some positivity. I think you should be able to do 1 and 2. I just talked about it at the end of today. Heck, number 2 looks awfully familiar. I wonder if that's the same answer as what we had in class today. Maybe a little different. But this one, I did intimate that you're going to have to use the Pythagorean theorem. I choose to do number 4 because I want you to do number 3. So look at this problem solving. Hey, that's a radius. So what's this length? Yay, my pen. I just love this. Oh, and I wish I could edit this out. My frustration with the pen consistently not working. 3, I know you're getting sick of hearing it. Well, I'm getting sick of it happening. But anyway, that's a radius as well. So you find that missing part by knowing that's a radius. And then what we mentioned today, that this is a right angle at a point of tangency with a radius. So lo and behold, I have a right triangle, and therefore I can use the Pythagorean theorem. I'm not going to solve it, but I will set it up. 3 squared plus x squared, the two legs squared equal the whole hypotenuse squared, which is 10 squared. All right. This was on my earlier notes, what those are called. So knowing what ZY is called. Yeah, just kind of look that up in your notes. I think I put that somewhere. And if you didn't take it down when we were talking about it, you're gone. Okay. Tell whether so this is in terms of the polygon. So make sure you answer that correctly. These are the walk around questions. We should be fine on that. I put 2 answers for 13. No big deal. We could just leave that alone. This whole section, you actually do not know how to do. So I'm probably going to wait and clarify that on Thursday/Friday. But I will say one little theorem here. When these are not radii either, but when a chord is hit by a perpendicular, this will probably get you to be able to do most of the section. Then the chord is bisected. All right. And then you see a lot of that going on here in this section. That should help you with 14, 15. You should be able to do 19. 17 should be good. And actually, 16 is probably pretty easy as well. 18, put a little star by that. Same idea, but you actually have to draw this and figure out what angle C is, and then trick yourself and draw your own altitude. And then it does what to that? And then also, what kind of triangles does that make? Let's see if you can figure that out from here. I think 20 through 22's got a few things going on, but I think you should be able to handle all of those. By the way, remember what kind of angle this is. This actually counts as an inscribed angle, right? So that also counts as an inscribed angle. That was stated in the notes before. But also, I mean, here's another thing. This is actually a radius, and it's hitting a tangent line at a point of tangency. So what else does that have to make x equal? So kind of a lot going on there that we should know. Now I think you should be able to figure out 26, and 27 is not as bad as it looks, but there is a lot going on here. So what I'm going to do is 25, and that hopefully helps you with this section, which is pretty challenging. And it's what's challenging about this is I have to kind of mark up the drawing for each one of these. So the first thing I'm going to do is, this is going to dictate all of the answers, by the way. What is this arc measure from here to here? Because this is a tangent. Angle Y is a tangent. So making sure you know that that's angle Y right there, because they have the arrows for Z and X. Ooh, there's the bell. So won't take too much longer on here because I just wanted to cover some of the tougher ones. And I really feel everything else you should be able to do. All right. So what is that arc measure? It's 120. And I really got to write that small in here because of our, multi-marked thing here. So what does that make angle O or X degrees? It's a central angle. So that is also 120 degrees. And then what does that make Y? Well, angle Y is a tangent angle. So that is 1/2 big arc minus small arc that it cuts. And it does cut those two arcs. And then this is the hardest one to visualize. So good, I didn't really mark up the problem, but I just talked about this on a previous question. Maybe I'll use highlighter. What is angle Z actually? And the answer to that is it's actually an inscribed angle. We have this all over the place on this worksheet. Number 24, that's an inscribed angle. Certainly number 20 is an inscribed angle. Um, 21, those are 3 inscribed angles. That's why I feel like that should not be a problem at all. And then number 22, X is inscribed, but it's also, you can do the radius to the tangent thing. Then, of course, 23 and 24 are inscribed angles. That's how you figure out what's going on with that one. You have to do a couple things there, then you could find X after you do those couple things. So Z is an inscribed angle. And what does that mean? It is equal to, in terms of the arc it cuts, half. So it's half of 120. That's what an inscribed angle's measure is. Okay? So I think 26 is a little bit easier. 27 and 28 are along the lines of 25. You kind of have to break it down and do a couple things. I'd start with this. What kind of angle is 54 degrees? Should answer that to yourself and then tell yourself, okay, then that makes this arc what? And then you go from there. I'd probably start with this one. 100 is here. And what kind of angle is that? So what does that make this arc? And then therefore I could find that arc. And then it becomes very similar to number 25. So it is kind of a bit of a challenge. Let's see if there's anything else. I think this is kind of challenging. I think you should be able to do it if you just really focus that this is a diameter and that cuts the circle in half. Then you can find those arc measures and corresponding angle measures. What is angle B to E to C? You should be able to answer that one right off the bat, what that measure is. Angle D is a little bit tougher. You got to do a little work to find angle D. You have to find this arc from here to here, which is not 180. That's just a little bit short of a half circle there. Same thing with this one. Oh, 1, 2, 3. This fourth arc, you should be able to find that. And then you should be able to find all of these angle measures because they're all, let's pick angle A. What kind of angle? And then angle A cuts this arc. What's the relationship between angle A and the arc that it cuts? So that's what we're looking for on that. Pretty standard here. This section, there's nothing tricky. That goes to 2 lessons ago. What happens? Oh, one thing about this one, I guess. I will set up 34. All the others are pretty straightforward. If this is X degrees, and this is a tangent, then what is this in terms of X? That's the trouble on this one. And the answer is this whole circle is 360. So whatever X is, this would be 360 minus X. And then you'd still set up what's true. Angle equals half big arc minus small arc. And then you would just have to solve. This one's very similar. This arc is one of the arcs that this angle cuts. What is this arc? Little bit different. You have to incorporate this and get that out of there to figure out what's left over for the other 2 arcs. And then this is some angle minus X. You can figure that out yourself. And then it's still angle equals half big arc minus small arc. All right. Don't forget this one is half arc plus arc. That's why it doesn't matter big or small arc. what's going on there. And then let's see if we have any other headaches. Okay, not too bad. What we have here is we do want to find this third arc here, whatever that is. And then we have a series of tangent angles, which is still half big arc minus small arc. And then we finally get some side measures there. What is that? Some side measures here. I guess I don't have too many of those. Outside times whole equals outside times whole. And this is just this over this equals that over that. Another headache question. Oh, that's a good one as well. So I'll let you tackle 38 and see if you get that one right. Another challenge there. And then review. Oh, come on. Hopefully you remember these. Do remember on this, they actually want you to find AQ, which is not a big deal. That's easy. But BC is not. This is when you had to use similar triangles in order to find BC. So I thought I'd throw that back in here because the top stuff was kind of, had some proportionality going on to the same thing with this one. This is, you have to use similar triangles to find Y. X is easy. Y, it's not the same. You got to find corresponding sides and set up those proportions. Okay, I'm done. I just wanted to help you on a couple. I really think this is a reasonable worksheet. Oops, I'm not done.